Okay, so today we'll just do one section, section 2.1, where we look at graphs of equations. Okay, so actually, you know what I'm going to do? The smart board, what's not working well for me this past few times, so I go to this other computer here, which is a tablet, and so just give me a second to get acclimated here. Hit the screen. Okay, so here's where we want to be at. We want to be able to do the following things by the time we're done with this lecture. Plot points. We'll be able to do that. Use the distance formula. Find the distance between 2 points. Good. Use the midpoint formula to find the midpoint of a line segment. Determine whether a point is a solution of an equation. Hopefully this isn't too difficult. Hopefully you've sort of heard of all these before. Sketch the graph of an equation using a table of values. That's pretty good. Find the X and Y-Intercepts of an equation. Determine the symmetry of a graph. That might be kind of difficult. And then finally, write the equation of a circle in standard form. That's a long list. We'll see how far we get though. Start off with plotting points. Is this thing gonna work? Nice. All right. So then we got the Cartesian plane. We have the y-axis, the x-axis. We have the points that we have are labeled with an ordered pair, where the x-coordinate is first, and then there's the y. Now the Cartesian plane has these 4 quadrants labeled in Roman numerals the following way: 1, 2, 3, and 4. So points can end up anywhere in any of those quadrants. They also could end up on the axis. And so I can give you points, have you plot them. I can plot the points and ask you to give me the coordinates for it, both ways. Right? Okay. So in the first quadrant, both the x and the y are positive. It's in the second quadrant that the x turns negative and the y is positive. It's in the third quadrant that they're both negative. And it's in the fourth quadrant that the x is positive while the y is negative. Okay. So if I give you a point, usually I use capital letters for a point, and let's say 3, -4. So the axis is usually marked off with tick points to tell you a distance of 1 apart, or sometimes if it's more than 1 apart, they have to tell you by the scale or something like that. Anyway, it's a bunch of tick marks here. And so we want to plot the point 3, -4. So this is your x and this is your y. The first one is directions on where to go from the origin. The point in the very middle is the origin. Sorry, just change the color real fast. So there's the origin. The origin has coordinates 0, 0. And you start from there when you go to plot the points. You go to the right 3, and then you go down 4. Don't make a point after going to the right 3. Don't make a point. Just stop there, and then go down 4, and then that's where you make your point. And then just label it by putting the letter there next to it. And hopefully this is straightforward. So it gets a little weird, I guess, if ever you have a 0 involved. Not too difficult, but a little strange, where you don't go left or right at all. You stay there from the origin, stay there with x, and then you're going to go up 4 since it's a plus. So this would be the point labeled B, and so on. Okay, hopefully that's not new, but that's how you plot points in the Cartesian plane. If I give you 2 points, we want to be able to find the distance between the 2 points. So there's a formula that we need. Okay. If you do have a nice plot, though, an easy way to find the distance would be to set up a triangle. But otherwise, we have this distance formula, which if you give me 2 points, x1 and y1 for the first point, and x2 and y2 for the second point, then you subtract the x's in any order. We tend to write it with the second one first. Subtract the y's in any order. You can screw that up, it doesn't matter. After you get that subtraction, go ahead and square each of those. Add those up, and then at the very end, take a square root. It just comes from the Pythagorean Theorem. If I have these 2 points here, I have a triangle that's made up from them, and we're trying to find the length of the hypotenuse. And to get the length of the leg, subtract the x coordinates. To get the length of this longer leg, we subtract the y coordinates. And it's just Pythagorean Theorem. Leg squared plus leg squared is hypotenuse squared. So you can plot it and use your geometry, or you can just plug into this formula. Questions about that? Let's see. Yeah, let's do it. Let's do it for these 2 points that we have here, A and B. What is the difference between the x's? What is the difference between the x's? What is x2 minus x1? Just 3, right? If we think of this as maybe, 0 minus 1, or 0 minus 3, or 3 minus 0, it doesn't really matter, because you're going to go and square that. What's the difference between the y's? It's going to be 8. You have a 4 minus a negative 4. I'm going to go square that. Alright, great. So the distance between A and B, the book, I think they have a symbol for that. They might try to say A, B with the line on top. Not quite sure. But anyway, the length of that line segment is found by taking the square root here. Alright, good. Run out of room. Sorry about this. So we have 3 squared, or negative 3 squared, and 8 squared. And then we take a square root. 8 squared, 64. 3 squared, 9. 64 plus 9. If it was somehow something you could do further than that, it comes from the fact that maybe, not in this particular problem, but maybe there is a perfect square that would go into that number, then you would go further. But it's at that point then that you'll be done. Okay. So you'll be able to use the distance formula to find the distance between 2 points. Good with that? Questions about that? All right, good. Use the midpoint formula to find the midpoint of a line segment joining 2 points. This already is getting too cluttered, so let me go to another slide. Keep all that. And this I'll record all this and post it. New slide. Okay, good. The midpoint formula. If I give you 2 points, how do you find the midpoint? It's going to be, I like to think about it as it's a point itself. It has x and y coordinate. I just like to think about it as the average x and the average y. I'm going to add the x's up, divide by 2. I'm going to add the y's up and divide by 2. It doesn't really matter how you write it, as long as you add and don't make a mistake of subtracting like in the other formula. That's all the midpoint formula is. Yeah, I guess we can go with that point. B was 0, 4. Yeah, we'll go with that. What's the midpoint of the line segment connecting A and B? It's a point itself. It has x and y coordinates. All right. We take the average of the x's, we add them up, divide by 2. We add up the y's and divide by 2. So what's the midpoint? 0 for y, definitely. What about for x? Yeah, 3/2 or 1.5 or 1.5. Good job. I mean, this is just using this formula. So we have the midpoint formula, and we have the distance formula so far. Are we okay with that? All right. Okay, good. So how are we doing on this list? Making our way through it. We can now use the midpoint formula to find it. So next up, we want to determine whether a point is a solution of an equation. Let me grab some examples from the text instead of me making up these quick examples. Let me grab one from the actual text. Determine whether a point is a solution of an equation. Where is that at? Let me grab some exercises. Okay, here we go. Determine whether a point is a solution of an equation. It's nice and big. All right, we're going to pick one of these questions here, 21 through 24. Okay, great. Take a screenshot. Okay, let me just grab all of them, and then we'll pick one to do. Okay. Determine whether each point is a solution of the equation. You know, it has a graph, and we're just worried about, you know, is this a point that's on the graph? We're going to plug in the x, plug in the y, and see if we get a true statement. That's all. So, all right, let's take 22. In 22, we have y equals 2x squared minus 7x plus 3. And we have these 2 points here with x is 1 and y is negative 1. I'm going to plug that in. See if we get a true statement. Y equals 2x squared minus 7x plus 3. I'm just taking this here and grabbing that. Sorry. Good with that? So, is it true? That's the question we have to, when we put equals here, we have to put it like a question mark over it. Is it true that when we plug it in, we get, you know, we get the left and right hand side the same? The left hand side, that's the easy part. That's just a negative 1. It's the right hand side where we have to plug in, it's not that bad. It's a positive 1, right? 2 minus 7 plus 3. So when it's a no, then that is not a point. So 1, negative 1 is not a point on the graph of that shape, whatever it is. We'll find out later that it's a parabola. Let's say it's not a solution. The other point might be, just because one point is doesn't mean the other one isn't. 3, 0. Let's check it out. If x is 3, right, the first thing is always x, the second thing is always y. If x is 3 and y is 0, is that a point on the equation? Is that a point on the graph? Let me write it down again. 2x squared minus 7x plus 3. Y is 0. Is it true? Question mark. That when I put a 3 in for x, it balances out and ends up as a 0. Is that true? In the order of operations, what should we do first? We should square the 3. Very good. And get a 9. Next, in the order of operation, we should do these multiplications. That's an 18. Take away a 21, but then add back on a 3. So, yeah, balances out. Yes, it's 0. So when it's yes, then we say that the point is a solution. Pretty straightforward, right? Pretty simple. Hopefully this is really simple, this section here. It will get more difficult later on, but not in this section. More likely not in this section. Alright, sounds good. So moving right along, we're making major progress. We can plot points. We can find the distance between 2 points. Oops. We can use the midpoint to find the midpoint line segment joining 2 points. We know how to determine whether a point is a solution of the equation. Halfway done, dude. This part's not so easy. Sketch the graph of an equation using a table of values. Find the X and Y-intercepts, that's trouble. Determining symmetry, that's trouble. And write an equation of a circle in standard form, not so easy. So consider this first part not too bad. It's the second part where all your trouble is going to come from. All right. So you get this chart, and basically they're giving you some x's, and you go figure out what the y's are. Straightforward. They don't give you too many of those examples, so I'll just grab number 20. I'll grab number 26. We'll get a much better way to graph this than what they have us doing. This is kind of like last resort. If you really want to graph something, this is how you go about graphing it. You pick some points for x, pick some numbers, plug them in, figure out what the y is, and plot those points. It's not the best thing to do, but sometimes that's all you got. So, let's grab that question. Okay. So y is 5 minus x squared. Here's some x's. They chose them for you. We could have easily chose them ourselves. And they're asking us to go figure out what the y values are and then plot them. Okay. So when x is negative 2, we got to go figure out what y is. Start with the easiest though. When x is 0, what's y? Right. When x is 0, then y is 5. Good. When x is 1, what is y? Very good. How about when x is negative 1? Square, you get the same thing. 5 minus a negative 1, you still get a 1. So that's also a 4. All right, good. How about when x is 2? Plug in, what do you get? That's 1. And when x is negative 2, also 1 again. Nothing's going to change. The fact that it's a negative, because it's squared, ends up balancing out. It's still 5 minus 4, which is 1. All right, good. And now they just want you to plot this. 0, 5. 1, 2, 3, 4, 5. The point 1, 4. That'll be right here. Negative 1, 4. It'll be right here. This is kind of last resort. If you really have to graph something, this is how you go about it. 2, 1, and negative 2, 1. Connect them, and we'll call that the graph of that function. Later on, we'll see that there's a way to get the graph of such a function by taking y equals x squared, normal parabola, and altering it, doing things to it, flipping it over the x-axis, and then shifting it. But anyway, that's what we're doing for now. Questions about that? It's not meant to be too difficult. The next part is a little bit strange. Finding the x and y-intercepts of a graph. We could actually take this one example here, but let's grab another one from the text. What you're doing when you're finding the x, you're actually doing the same kind of chart thing. If you're trying to find the x and y-intercepts, you know what the x-intercept is where the function hits the x-axis. What the y-intercept is where the function hits the y-axis. And so, when you're asked the question, find the intercepts, that's another sort of along the way of trying to figure out how to graph something, it's good if you can find out where it hits the different axes at. And so, but it's just plugging in x equals 0, figuring out y, plugging in y equals 0, and figuring out x. Some are easier than others, though. Oops, I don't know what just happened. I think it's fine, though. New slide. Yeah. Okay. So the process of finding the x and y-intercepts turns into plug in x, figure out y, plug in y, figure out x. And so, why does it default to red every time? So I like to think about, like, I'm going to fill out this chart where I plug in x equals 0, I go figure out y, I plug in y equals 0, and I go figure out x. That's all. The easier way is this first way. This is I'd say 9 times out of 10 going to be, even 95% of the time, it's going to be easier to do this, plug in x equals 0. This generally will be much harder to do, plug in y equals 0. Especially with the functions like this where it's solved for y. Let's see, of these, let's look at 2 of them. Let's look at number 32 and number 34. That way, if you want to go try some, you can try those odds and check the back. When I pick a problem, I'll try to remember to pick some even questions. So, I got this function y equals x times the square root of x plus 5. Okay, let's do the easy thing first. Let's plug in x equals 0. What does that mean for y? If x equals 0, plug into this function 0 times the square root of 0 plus 5. Y is going to be 0. You get this root 5 here, but root 5 is going to be multiplied by 0. So, yeah. You end up with 0, 0. That's the origin. Sounds good. That will be true. That's one of your points. Now, sometimes you actually, when it comes to x-intercepts, that's what these guys are, x-intercepts. This is a y-intercept. When it comes to y-intercept, there will only be one, if there is any at all. But when it comes to x-intercepts, there could be multiple. So for x-intercepts, it could be more than one. But when it comes to y-intercept, there's either one or none. So we have the origin. X is 0, y is 0. And the origin kind of serves as both, right? Whenever you get the origin, that's both an x-intercept and a y-intercept. Okay, so let's go through the last part of this where we plug in 0 for y and try to solve what x would be. Here's where it becomes a little bit more difficult than it should be. We have to solve this equation for x. What's nice about it is that it's a product and it's equal to 0. That's a good thing. 2 things multiplied by each other to give you 0. Treat it like if it was the things that were, when we're factoring, we got two binomials, we're factoring, trying to get to 0. We take each one separately and set equal to 0, use the 0 property. Do the same thing. Take the x, set it equal to 0. That's just getting the origin again. Take the root, set it equal to 0. So either x is 0 or root of x plus 5 is 0. That's the only way that's going to work out, to be a product of 0. Okay, this first piece isn't new information for us. That's just the origin again, 0, 0. But the second piece, we'll be able to get something origin that. How do we solve that? What should we do to solve that? Square both sides? It's already square root. To undo a square root, you got to square it. Square both sides. Squaring 0 is just 0. Squaring the square root, you get what's underneath. So x plus 5 then has to be 0. You can either reason out, how could you take the square root of something and end up with 0? Is that the something underneath must be 0. that means that x is negative 5. All right, good. X is negative 5. That's your other x-intercept. So we have 0, 0, and negative 5, 0. If it shows up twice, like 0, 0 does, that's it. It's okay, just report it once. So these are your intercepts. 0, 0, and negative 5, 0. These 2 points are your intercepts. Okay. 34 is a little more difficult because it's not solved for y. In 34 we have x squared y minus x squared plus 4y equals 0. Not your standard way of having a problem. Normally we like to have y equal something. We'll take it as it is though, and go with the process of plugging in x equals 0, plugging in y equals 0. With these kinds of functions, what happens is you might be able to get 2. I mean, it's probably not going to end up being a function. Let's see. Yeah. I don't know. Let's see. We might end up with 2 y-intercepts. That would not be a function. What happens when you plug in x equals 0? What do you get? X equals 0. What happens to this term when you plug in x equals 0? Sure. This term is also 0. Both of those are 0. So you end up with 4y equals 0. Those guys zero out. So it's nothing new here. It's just that y is 0. It's the same kind of thing. How could you have 4y equal to 0? It has to be that y is 0. So we keep getting the origin. The origin doesn't always come up, but in our 2 examples that we chose, it came up. And that's the only choice for y. Now when it comes time to set y equal to 0, then we might get something different. If I set y equal to 0, then x squared y, when y is 0, x squared y is 0, so that part zeroes out. 4y is 0, that part zeroes out. So then you're left with, I picked a bad example. Wow, that's such a bad example. Sorry. 0, 0 again, just the origin. The origin is the only intercept. I guess I have to really think about it before I pick them. That was not how it's supposed to come out. It's all good though. Questions about that? I'm going kind of fast, I'm sorry. Slow me down. Yes? Yes? Oh, so
What was the first one? Technically the x-intercept?
At first we were setting x equal to 0.
Yeah.
And getting y. When we set x equal to 0 and get y, you're getting the y-intercept. When you set y equal to 0 and try to get x, that's getting the x-intercept.
I was just confused with that.
Yeah. Alright, sounds good. So, where are we in the big scheme of things? Only 2 more to go. 2 more concepts to go. I don't know why all these concepts are sort of smashed into this one section, but anyway. Making our way through this list. Sketch the graph of a function by getting the table. Find the x and y-intercepts. Okay, next up, determine the symmetry of a graph. That's not an easy thing. And write the equation of a circle in standard form. Let's go with that. Equation of the circle in standard form and symmetry of a graph. All right. Trying to escape. Okay. Go back to the textbook. For this time, I'll go back and grab some. The textbook has a good box that explains how to find this symmetry. Yeah. Okay, good. There's x-axis symmetry, there's y-axis symmetry, and there's origin symmetry. Okay. X-axis symmetry, y-axis symmetry, and origin symmetry. What does that mean? If you were to flip it across the x-axis, you get the same picture back. If you were to flip it across the y-axis, you get the same picture back. It's a mirror image across the x-axis, or a mirror image across the y-axis. Origin symmetry is very different. Okay, it is, if you were to sort of, whatever's up in this first quadrant gets reflected. I guess if you want to think about it, maybe reflected about the line y equals negative x. I'm not sure the best way to say it. But, yeah, the x's become negative and the y's become negative. And so you kind of reflect about this kind of line here for origin symmetry. Whatever's in this first quadrant gets reflected about the origin over to this third quadrant. And vice versa. If there's something in the second quadrant, it'll get reflected over the origin and end up in the fourth quadrant. So if you have a picture, you can tell by the picture, but you're not going to be given a picture. You're going to be given just the equation of the function. Okay, so here's what it means. This is the definition of symmetry. But you want to know, well, how do I have a formula and I check for symmetry? Okay, so so we said you're flipping across the x-axis. What that does for you is basically replaces if you're flipping about the x-axis, you're replacing y with minus y. Makes sense. Okay, if you're flipping about the x-axis, whatever's here on top is now coming down here on the bottom. And so the definition officially then is going to be whenever xy is on the graph, at the same time x negative y is on the graph. So you keep the same x, but your y, which is positive, now has come down here and is negative. It's official definition of what x-axis symmetry is. Over here, keep the same y, and your x's change sign. It's kind of a mirror image across the y-axis on this one, mirror image across the x-axis on that one. xy is becoming minus xy. And then for the origin, it's a double thing. Both the x and y are changing signs. So if you got a point that's here, flip the signs, make them both negative if it's there. And this other point is also on the graph. Negative x, negative y is also on the graph. That's the definition, but how do you check it? How do you know? If I give you a formula, how do you check it? That just says what it is. It doesn't say how to go and find it. It gives you kind of an idea, but what we really need to see is maybe some steps. So in the textbook, what they do is they give you steps on how to go and check this for yourself. Let me find that for you. Just go take these steps from the next page. There we go. We have it there, and so we just have to check it. So checking it, testing it, is doing exactly what we said. Replace y by minus y. See if you get the same thing back out. That's x-axis symmetry. Replace x by negative x. See if you get the same thing back out. That's y-axis symmetry. And then replace x and y by negative x and negative y, respectively, and see if you get the same thing back out. So that's how you're going to do your test. You'll be given a formula, and you'll be asked to test the formula for symmetry. And here are the tests, basically, coming from the definitions. Replace y with minus y, see if you get the same thing back out. Replace x with negative x, see if you get the same thing back out. That's y-axis symmetry. And then finally, replace x and negative x with x with negative x and y with negative y, see if you get the same thing back out. Okay. Replacing y with negative y yields an equivalent equation. Get the same thing back out. That's called x-axis symmetry. Replace x with negative x. Get the same thing back out. An equivalent equation. That's called y-axis symmetry. Replace x with negative x, replace y with negative y, but still get the same equation back out. That's called origin symmetry. So if someone goes and gives you a formula, you check these three things. They don't tell you, like, check it for y-axis symmetry. They just say, check it for symmetry. And so technically we need to go through all three. We probably have an idea just by looking at the formula which one really is going to work. But it comes from trying a few of them. Let me grab some of the examples from the text. If I'm going too fast, I'm sorry. Just slow me down. Jumping. These topics, they seem to be disconnected in this particular section for some reason. Let's see, where are the exercises on that? We might not get to that last topic, but that's okay. Check for symmetry with respect to both axes and the origin. That's what they say. We'll pick maybe one of these to do so we can still have time to try the other part. Okay, so let's pick one of the harder ones maybe. Okay, let's see, maybe number 46. All right, there's three different checks. Number one, replace y with minus y. See if that gives you the same thing back out. So I have this function, y equals x over x squared plus 1. And they want me to see if I can replace y with minus y. Negative y takes the place of y. Do you get the same thing back out? And the answer is no. If I replace y with negative y, and there's no y's on this other side here, I don't get the same thing back out. I got this negative sign here that doesn't get, canceled out. If you want to solve it for y, maybe, and like times everything by negative 1, maybe, you'll see that on this one you have y equals x over x squared plus 1, but on this one, when you times by negative 1, that'll get you the y back on the left-hand side, and that'll put a negative 1 on the other hand, on the right-hand side. So no, that's not the same. When it's not the same, you don't have that kind of symmetry. So that's a no to x-axis symmetry. The answer is no. For y-axis symmetry, we're going to replace x with negative x. Negative x replaces x. See if you get the same thing back out. So when I want to put an x, I put a negative x. When I want to put an x down here, I put a negative x. And what's different about it is that you get the same denominator. You square this out, it'll be x squared plus 1. You get the same denominator, but it's that numerator that's different. And so altogether, the whole thing is different. It's going to not be the same. So that's a no to that, too. If the exponent wasn't there, that plus 1 would throw us off. Yeah. That plus 1, because that doesn't change. That plus 1 stays as it is. And so, yeah. I think, though, we do end up with Yeah. We do end up with this last one, origin symmetry. I used up all the space, huh? All right. Replace x with negative x, and at the same time, replace y with negative y. Oops. Okay, so we have the function was y equals x over x squared plus 1. The third check is negative y replacing y, and at the same time, negative x replacing x. Okay, let's see what that does. So negative y replacing y, negative x replacing x. So every place I see an x, I'm going to put a negative x. Every place I see a y, I'm going to put a negative y. And I think you end up back where you start at. This denominator doesn't change. That stays as x squared plus 1 like we saw last time. But the fact is we have this negative here and now this negative here. And we could do the same thing like, multiply by negative 1. Or if you want, we can say we can cancel those out. I think it might be best just to say that, a negative on the left and a negative on the right can cancel each other out. So that we actually have the same thing that we started with. This is the same as the original. And when that's the case, when you get the same as the original, then you get that kind of symmetry. So yes to the origin symmetry. That was a little strange. And you don't always get symmetry. Like, you could get no to all three of them. This just happens to be, yes to the third one and no to the first two. Okay, finally, in the time that's left, I'm going to look at circles. Write the equation of a circle in standard form. All right. You just need to be told what it is, and then the hard part is just making it happen. What is it? What is the equation of a circle in standard form? With a circle, there's a center and there's a radius. So the standard form of a circle that has a center of hk and a radius of lowercase r is in this format here: x minus h quantity squared plus y minus k quantity squared equals, not to r, equals to r squared. Okay, that's the standard equation of a circle. And so we now can, if I give you the center and I give you the radius, you're just going to plug into it. Plug into the formula and leave it in that form. Don't have to worry about trying to simplify it. Just leave it in that form. So that's going to be the easier kind of question. If you're given the center and given the radius, the harder question is going to be when one of those, or maybe something, you don't have complete information. You have to sort of figure it out. So if I go and give you that the center, let me do it as negative 3, 2, and the radius is, let's say 4. Okay, technically what's going on here is we have this negative 3, 2. What a circle is the locus of all points that are the same distance away. All the points that are a distance 4 away from the center is the origin. Is the circle. Those are the points that are on the circle. And so if you were to graph it, I recommend just going up 4, down 4, left 4, and right 4. If you ever had to graph a circle, go up the radius, go to the right the radius, left the radius, and so on, and just connect them with the circle. If they ask you to ever graph a circle. But they don't ask us to graph here. They just want the equation. in standard form. So we're just going to plug in hk. This negative 3 is an h. This 2, that's a k. So when you go into the formula, it has this sort of format to it. And so, be careful though, you're supposed to subtract the h, and subtract the k. If you already are subtracting a negative, it ends up flipping the sign around. Here you're subtracting a 2. Don't forget that these things need squares on them, otherwise you don't have a circle. So you got your right-hand side, then your left-hand side is you take the radius, whatever it might be, and square it. So for us, that's going to be 16. Is that too fast? I'm going really fast. Sorry about that. Just, you end up basically flipping the signs on these. So if it's a negative 3, and here it's going to be a plus 3. If it's a positive 2, and here it's going to be a negative 2. Flip the signs around. Okay, so how do they make this difficult? If maybe they give you the multiplied out version of this, or you have to do something like complete the square to find it. That's what makes it difficult. You have to square the radius. The radius is 4. All right, good. Here's the problem when it's in this ax squared plus ay squared plus dx, plus, everything kind of multiplied out. Like that's when it gets ridiculous. You have to complete the square to figure it out. Let me grab an example from the exercises. Yeah, so they give you this circle. They say find the equation. If I give you the circle, you just need the center and the radius. Diameter's, twice the radius. If they ever say the word diameter, that's twice the radius. Let's see if we can do number 84. And we'll save the completing the square for next class, because that gets really involved. Let's see if we could do number 84, where we have incomplete information. We don't have the center, nor do we have the radius in number 84. In number 84, we have a circle that's graphed for us, and a couple of points that are on the circle that are labeled. And they tell us in the directions, let me get the directions too, I'm sorry. In the directions, they say that those 2 points that are labeled on the circle, it's very important that they say this, those points are endpoints of the diameter. Okay, so we're just going to use what we learned earlier to get what the equation of the circle is. We need a center and a radius. All we have are the endpoints of the diameter. How are we going to get the center if we have the endpoints of the diameter? How do you recommend we're going to find this point that's right in the center? Good.
Use the distance formula from the 2 points, and then once you get the diameter, cut it in half and make the radius.
Distance formula will give you the diameter. Half of the diameter is the radius. Good job. What about the center? How are you going to get the center? If I have this point and this point, how do I get the point that's in the center between them on the line segment that connects? Find the midpoint formula. The midpoint will give you the center. Good job. All right. So what are our points? Negative 6. Negative 6 and negative 3. That's 1 point. And the other point? 1 and negative 5. All right. Distance formula. Okay, what are you supposed to do? You got this square root business. What do? You subtract this x's, subtract the y's, square them. Be careful about sign. Don't go so fast that you make a sign mistake. And don't get the x's and y's mixed up. Right? If I'm subtracting the x's, I take a negative 6 and I take away 1. I take a negative 3 and I take away a negative 5. Very tricky. You could make an easy algebra mistake in that. You can go left or right, as long as it doesn't matter the order here. You can screw up the order in this. Because you're squaring it, it doesn't matter the order. So anyway, what do you get? You get a negative 7 that you need to square. Be careful with this next guy, though. That's not an 8. What is that? You're subtracting a negative? That's really adding in disguise. That's a 2. So, we take 49 and add on 4. How do you get the 4? You got to square the 2. And that's not going to be anything nice. That's just going to be 53 underneath a root. That's what the distance is. 53 under the root. Just take half of that, and that's what the radius is. Right, whatever, leave it just like that. How about the center? We go to the midpoint formula, where we take averages. This time we're adding the x's up. Negative 6 plus a 1, dividing by 2. Adding the y's up. Negative 3 plus a negative 5, divide by 2. What does that give? Adding the x's, we get a negative 5. Adding the y's, we get a negative 8. But dividing by 2, we get this negative 5 halves and negative 4. That's our center. That's our HK. Final step to put them into the equation. X minus h, quantity squared, y minus k, quantity squared, doesn't equal the radius, equals the radius squared. Okay, what goes inside? What's x minus h? It's going to be x plus 5 halves. What's y minus 4? It's going to be y plus 4. Here comes the weird part. What's r squared? If r is root 53 over 2, you want to square that? You're going to have to square the root 53 and square the 2. Right? When you square a fraction, you're squaring the top and squaring the bottom. Squaring the square root, you just get what's underneath. Whoa. I don't know what happened. Sorry about that. That's a sign that we have to finish. Get the heck out of here. That's 53 over 4. You okay with that? That's what's on the other side of this equals. All right, have a good week. I'll see you guys on Tuesday. That was a lot. We did a lot. And we started late. Good work.
That's where I should go with it.
They want the standard equation? We got it.
Like you don't have to like figure out anything else with that.
That's the standard form. We're done.
Okay.
Yeah. Yeah.
Hi, I had a question about the next exam. Is there any?
Oh, you don't want to email me about going away?
Yeah.
I don't think that's going to stay that day. I think what happened, I just picked random days because like I had to basically pick all these assignments out, and then I had to pick like some day where they're all due. But on the syllabus, does it say that there's an exam on the 6th?
Unless I misread it.
No, let me check.
I just wanted to be safe before I booked my plane ticket.
Yeah. You want to go away? Huh? Let's see. So what is this? 107.81. Dang, that's what we said. I don't think we're on track for that. Let me check.
Okay.
Syllabus. I don't think we're on track for that. October 6th, huh? I don't know. How many more days we got before then?
Not sure.
No way. Look at all the material we have to cover. No way.
It's like
Book your
less than 2
ticket.
weeks or
Enjoy your break.
All right, thank you so much. See you Tuesday.
It's Laura, right?
Lauren.
Lauren. Okay, all right. See you.